Hey, so we're going to talk about pH in this video right here. So here's some formulas that we're going to work with. I'll go ahead and start explaining those here with the pen, and then we'll get started doing some sample calculations. So the first one, if you look, the pH plus your pOH is going to equal 14. Remember that when we say pH, we're talking about the power of H plus. When we say pOH, we're talking about the power of OH minus. So both of those are talking about a scale. pH is saying how acidic am I, and pOH is answering the question that we really all have to answer every day, how basic am I? And remember that those two add up to 14. On the next one, we can introduce a logarithm, which you remember is a function that we use to kind of help make numbers smaller and take something that's exponential and make it linear on a graph. So if you look here, the pH equals the negative log of H plus. Don't forget that that bracket is going to mean concentration. Okay, and that's referring to molarity, right? The same formula is also true for pOH, and instead you just replace OH minus with H plus. So if you are using an acid, something like HCl, you would use the pH equals negative log of H plus equation. If you're using a base, something like NaOH, you would use the pOH equation. If you take those logs and you try and eliminate the log from the equation, you'll get the next two. The first one here says the concentration of H plus equals 10 to the exponent negative pH. So if I give you a concentration, like I tell you how much H plus you have dissolved in a solution, you can use that to figure out, or sorry, if I give you a pH, you can use that to figure out how much H plus you have in a solution. The same thing is also true if I give you a pOH, you can use that to figure out how much OH minus you would have dissolved in a solution. And finally, the first formula up here and the one down here are very similar. This one says H plus times OH minus is going to be equal to this value 1 times 10 to the negative 14. And with that, we actually have all of the equations that we need to start using problems. Okay, so for this problem, you're going to calculate the pH of something that is 1 times 10 to the negative 4 molar HCl. Don't forget that molarity is talking about moles per liter or moles divided by liters. So this is saying that you have a solution that is hydrochloric acid, and you need to calculate the pH of it. For the most part in chemistry, if you have something that starts with an H, you're dealing with an acid. If you have something that ends with an OH, then you're dealing with a base. So in this case, we have an acid, so we can plug this into the equation. So if you look, we'll set up our equation. pH equals negative log of the concentration of H plus, right? The nice thing is that this number, since it is a concentration, can be plugged in directly there. So if we were to rewrite the equation, it would be pH equals negative log of 1 times 10 to the negative 14. The great thing about the properties of logs, you can plug that in if you wanted to your calculator. However, if you ever end up with something that is 1 times 10 to an exponent, you can directly remove that exponent, and then you're going to multiply it by negative 1. So in this case, oh, and it's not 14, it is 4. Excuse me. So 10 to the negative 4, you can take out the 4, make it positive, so your pH of this equation is 4. pH does not have units, which should make you happy. Okay, so using the same method that we did for the last one, in this problem you're going to calculate the pH of something that has a little bit less H+. So if you look, here's our compound that we're working with. It is HCl. So what does that H mean again? We're working with an acid. Good. So you're going to take pH as your equation. That's what you have to solve with. You take what you start with, okay? That becomes negative log of 1 times 10 to the negative 6, because remember that this is that concentration of H+, right? So here we have 1 times 10, which means what can we do? We take this exponent out, you multiply it by negative 1 because there's that minus sign in the front, and this becomes a pH of 6, okay? Those two are a little bit simpler problems. If I had asked you in this one instead, what is the pOH, you can answer that really quickly now with the information that you have. You would rearrange this equation pH plus pOH from the beginning equals 14, and you'd instead plug in 6 right there for pH, and you'd have pOH equals 14 minus the pH, which is 6, what we just said. So your pOH is 8. Okay? Now let's look at a harder question. Okay? Calculate the pH of 2.5 times 10 to the negative 5 molar HNO3. This starts with an H. It's actually nitric acid. So you are allowed to plug this directly into the pH equation. However, you're definitely going to have to use a calculator at this point to get an exact value. So remember, pH is negative log the concentration of H+. We have a concentration of H+. It is this, right? So we can go ahead and plug in 2.5 times 10 to the negative 5. And then go ahead and punch that into your calculator, and I'll give you a second to do that. Okay, so don't forget that negative in front. Your pH should always end as a positive number for the most part. So you should get something that is 4.6. And then if I had asked you your pOH, don't forget that you just do the same thing where you do 14 minus 4.6. And then you could calculate the pOH. And that pOH in this case would be 9.4. All right. Remember, the pH scale here is saying with this solution of nitric acid that you're working with, how strong is it on a scale of acidity? And then the pOH here is saying, all right, with that same solution, how strong is it on the scale of basicity, or how basic is it? Acids on a base scale will run from 7 to 14, and acids on a pH scale will run from 0 to 7. Okay, so here now we have a little bit of a more complicated problem. Find the pH of a 250 milliliter solution where the concentration of H+ is 1.3 times 10 to the negative 4. If you notice, you have a concentration of H+, and the formula that we've been using for the past few problems has been pH is negative log of the concentration of H+. So a lot of times, chemistry teachers will like to be mean, and they'll throw stuff into a problem that you don't always need. So this is saying, if your amount of H+ is 1.3 times 10 to the negative 4, do you really need this measurement of volume? Is that useful to you? Your answer should be no. Why? Because you can just plug your concentration right in there, and that does give you pH, and you don't need to use the volume. So we're going to do that. We're just going to say negative log of 1.3 times 10 to the negative 4. And I'll give you a second to go and punch that in your calculator. And that should give you 3.9. Is that what you got? Perfect. Okay. This one is super easy as well. So what is the pH if the pOH is 3.7? So our equation that we've been using a couple times now, pH plus pOH equals 14. So pH, we're just going to substitute directly in, plus 3.7 is 14. 14 minus 3.7, your pH equals 10.3. Okay, here, you're going to find the pH, and they tell you that your OH minus is 1.7 times 10 to the negative 8, which means that they've given you, essentially, in your solution, how basic it is, okay? They want to figure out how acidic it could be. Okay, so remember that with acids and bases, you're kind of working on a balance or a scale where you have, for instance, on one hand, which my hands are far away, okay, on one hand you have H plus, on the other hand you have OH minus, and they're balancing out, okay? So what we're going to do, we're actually going to pull out the equation H plus times OH minus equals a constant 1 times 10 to the negative 14. Okay? As you can see, you're definitely going to plug in that for OH minus. So you have 1.7 times 10 to the negative 8 equals 1 times 10 to the negative 14, and you have H plus still. Don't forget that you're going to take and divide both sides by this number to get H plus by itself. So the left side of your equation should read H plus equals, and then you're going to do 1 times 10 to the negative 14 and divide that by this number here, 1.7 times 10 to the negative 8. So I'll give you a second to do that. Okay, so as you do that, make sure that you put parentheses around the 1.7 times 10 to the negative 8, since you're going to be dividing by something that has an exponent. You want to be careful about order of operations. So if you did this correctly, you should get a number 5.888 really times 10 to the negative 7, and you could round that to 5.9 if you wanted to deal with sig figs. And that tells you how much H plus you have in your solution. Okay, so let's do another similar problem. Instead, we're asking H plus if you have POH, whereas last time I gave you the OH minus. So what are you going to have to do here? Well, you have a POH, and you want to figure out H plus, which comes from being acidic, right? Or donating H pluses to a solution. So what we can do, actually, I'm going to take my equation where I do 14 minus my POH equals pH. And if I plug 3.7 in, I end up getting a pH that is 10.3, right? Now, if we look back, there should be an equation that we can use where we plug in a pH, and that tells us how much H plus is present in the solution. So if you ever see this, you're going to have an equation where you put H plus equals, and here's your formula, 10 to the exponent negative pH. So for ours, we would do 10 to the negative 10.3. And if you go ahead and punch that into your calculator, as I will do right now, you should get 5.0 times 10 to the negative 11. And these are all for concentrations. Those are all going to be a molarity. And with that, that's it. I'd like to go back real quick. Remember, here are your equations. We would give you these all in class. After a lot of practice, I'm sure that you'd be able to use all of them with ease. So what I would do, I'd recommend watching this video a couple times until you're really comfortable with working through all of these without my help. And then, as always, see me in class if you have any questions. Great. Have a good day. Bye.